All right, now we're going to do these exact same questions again. We're going to start with the exact same 4 scenarios, but we're going to change it to the word or. So the first step is to solve and graph. So you're going to solve each inequality individually and put them on a graph. So these are again -3 and 5. So my first scenario, I'm going to put the -3 on the left and the 5 on the right. This is x is greater than -3, which is a round bracket with an arrow pointing up to the right. Then we're going to do x is less than 5, round bracket with an arrow pointing to the left. The biggest difference here is we're going to switch to the word or. When it was and, it had to satisfy both inequalities, so you were looking for where the graphs overlapped. With the word or, you're looking for anywhere there's a graph solution. Because if you think about the numbers themselves, okay, if I pick a number down here like -4, is -4 greater than -3? No. But is -4 less than 5? Yes. So as long as it satisfies one or both of the inequalities, it's a solution to the union of these two compound inequalities. So -4 didn't work for both, but it did work for here. If I pick something like 0, 0 is greater than -3. Yep. 0 is less than 5. Yep. It satisfied both. Great. And then if we pick a number to the right, like a 6, is 6 greater than -3? Yep. Is 6 less than 5? No. But that's okay, because it only has to satisfy one or both of the inequalities. So what would my solution be for this? Well, anything. When your arrows point in opposite directions like this with that overlap in the middle, the answer is absolutely all values of x will make one or both of these inequalities true. All right, let's try this next one. So if you remember from the previous page, this is the one where the arrows point away from each other instead of towards each other. So x is less than -3 is an arrow pointing to the left. X is greater than 5 is an arrow pointing to the right. Now, where are their solutions? Well, all of these values will satisfy x is less than -3. All of these values will satisfy x is greater than 5. So as long as it's in one of these two sections, you're good. How do we answer that? Well, we take this graph and we make it into inequality. Everything from -infinity to -3, or, so that union symbol, that U, everything from 5 to infinity. All right, next one. For this next one, again, we're going to put this on a graph. We've got a -3, we've got a 5. X is greater than -3 is a round bracket opening to the right. X is greater than 5 is also a round bracket opening to the right. Now we're looking for anywhere there's a graph. So the only place that won't have a solution is down here. The solution will be everything from -3 up to infinity, because all these values will satisfy one or both. So -3 up to infinity. So the biggest difference I find between and or is that for these questions you go from the bigger number up, and for an or you do the smaller number and up, because it's anywhere there's a graph. Okay, why don't you try this last one? X is less than -3 is a round bracket opening to the left. X is less than 5 is a round bracket also opening to the left. And again, we're looking for anywhere there is a solution. So for these, it's going to be anywhere from 5 down to -infinity. So my interval notation will be 5 down to -infinity. Awesome. So those are your 4 scenarios. So again, scenario 1, where the arrows overlap and keep passing each other, then the answer is everything. When the arrows go away from each other, it's both of those two sections with the or symbol in between. When they overlap in the same direction, always go from the smaller number when it's going greater and from the larger number when it's going less. Awesome. 2 questions for you to try on your own, or maybe together. So for this first one, I'm going to get x by itself by adding 2 to both sides. I end up with x is greater than or equal to 1. And maybe let's just sketch this while we go. So, oh, actually we can't yet because I don't know if that's going to be the smaller or the bigger number. Okay, let's -4, -4. and I get x is less than or equal to 8. Okay, so it was smaller. So we've got 1 and we've got 8. For this left inequality, we've got x is greater than or equal to 1, so square bracket opening to the right at 1. And then we have x is less than or equal to 8 is a square bracket opening to the left at 8. Now, because my linking word is an or, anywhere there's a graph, it's a solution. So it's really pointing down to negative infinity and up to positive infinity. So my solution in interval notation would be negative infinity to infinity. All right, last one. So for this one, again, I have that linking word or, minus 2, x is less than or equal to 1. And then for this one, I'm going to minus 1, negative 2x is greater than or equal to negative 4. Then I'm going to divide both sides by a negative number, which means I'm going to flip my inequality. And you end up with x is less than or equal to 2. All right, and then let's sketch this compound inequality. Let's do it over here. X is less than or equal to 1 is smaller, and then we've got 2 is bigger. Less than or equal to 1 would be a square bracket opening to the left. Less than or equal to 2 would be also a square bracket opening to the left. Oh, I didn't change my color. Be consistent. Square bracket opening to the left. Awesome. Okay, now is this a linking word and or is this a linking word or? Since it's the word or, you're looking for anywhere there is a drawing. So it's going to be from 2 down to negative infinity with a round bracket, right? So with this one, it was anywhere there was a drawing. Awesome. Hopefully that's feeling good. Give these a go. They are tricky, but once you get used to them and maybe writing these rules down, right, maybe these 4 scenarios really help you. And that's really all they can ever ask you to do once you've solved the inequality.